Let's calculate the work required to empty a tank full of water, pumping the water over the top edge. The tank is a right circular cone of radius 4 feet and height 6 feet. Let's place the cone in a 3-space rectangular coordinate system such that the tip of the cone is located at the origin of the system. I'll start with a partition delta on the z-axis. The interval 0 to 6 is cut into n intervals. I'll work on the ith interval from z sub I minus 1 to z sub I. The plan is to calculate the work done by the force on the ith interval of that partition. Let's consider a slice of water, this one, corresponding to the ith interval. Because its height, delta zi, is small, I can assume that the force is constant. The force equals the weight of that slice of water. The work on the ith interval can be calculated using the simplified formula weight times distance. Knowing that the weight of 1 cubic foot of water is 62.4 pounds, it follows that the weight of the ith slice of water equals 62.4 times the volume of that slice. As the ith slice of water is a thin slice, I'll approximate the volume of that slice by the volume of a right circular cylinder. You see here a right circular cylinder. The height of the cylinder is delta zi, the length of the ith interval. To find the volume of the cylinder, let's consider a point P of coordinates x, y, z on the bottom of the right circular cylinder. It follows that the radius of the cylinder equals y. From here, from P to the z-axis, we measure y. As I started with a partition on the z-axis, the definite integral that calculates work will be with respect to z. Therefore, I need to express the volume of the cylinder as a function of z. Triangles OQP and OAB are similar triangles. Then, y over 4 equals z over 6. Finally, y equals 2z over 3. And the volume of the ith slice of water equals pi times the radius square, which is 2z over 3, times the height, which is delta zi. To empty the tank over the top edge, the bottom of the slice of water that we are talking about has to travel from point Q to point A. As from A to O it's 6 feet and from Q to O it's z, it follows that that slice of water will travel a distance 6 minus z. The work done to evacuate the ith slice of water equals force, which is the weight of that slice, times the distance. Once again, the work done to evacuate the ith slice of water equals the weight, which is expressed by formula 1, times distance traveled, which is 6 minus z. Total work required to empty the tank is approximated by the sum of the works on each of the n intervals of partition delta. This is a Riemann sum, and if the limit of that Riemann sum exists, then the work can be expressed as a definite integral from 0 to 6. These are the limits for z, 0 to 6. of a function of z with respect to z. The integrand, the function of z, is this function represented by the formula labeled formula 2.